Problem number 3. So we have a stack, and in this problem we have to reverse it. So, and reverse it, we can use just one variable, temporary variable, which will be like any type of data, like integer or whatever, and the second stack. So how are we gonna do this? So for example, in a given stack, we always the first element we will be always putting to the temporary variable, and all the other we will be putting to the second stack. So it will be in this order since it's a stack. So after that, we'll put our temporary the element from our temporary variable back to the initial stack, and all the elements from the second stack. So, and again, we'll do the same thing with the top element. We'll put it to the temporary variable and put other elements to the second stack. All elements, but the first element will be kept in the first stack. So after that, we'll put back the element from our temporary variable and back our elements from the second stack. And again, we will put our top element to the temporary variable and put our other left elements to the second stack, but we'll leave the elements that we just returned from the temporary variable. And again, we'll just put the element from the temporary variable back to the initial stack and the element from the second stack. So at the end, we will just reverse our stack and we will just return it. And code will look like as following. So here we will just return stack. Let's consider that the stack will be integer, but since it's a generic value, it could be any type of data. So let's call it reverse stack. The input and the passing value will be also stack. Let's call it just stack. So to reverse this stack, we will declare another stack, the same data type with the first stack, and we will call it just basically second, referring that it's a second stack. So we will use for loop just to iterate through all elements in the stack. So our stack will be run until it will reach the end of first stack. So here we'll use our temporary variable, and to temporary variable we always put the top element from our first stack. And we will use counter. We use counter because we always will need to keep our elements from the temporary variable that we will put back to the first stack untouched, because we want to them be there in order to get the reversed result. So our counter will be always the number of elements in the first stack minus I, which always will be incremented according to the loop. So here we'll use while loop, and we will run it until our counter will be equal to 0. And after we take first top element to the temporary variable, other elements will always push to the second stack, popping it from the first one, and always decrement the counter. After we will push them to the second, we will just push back to our initial stack the element from our temporary variable, and redefine our counter, making it equal to the number of elements in our second stack. So this counter will be just to push our elements from the second stack back to our initial stack. Again, we will run this while loop until it will reach the end of the second stack. So we'll push the elements from the second back to our initial stack, and at the same time we'll always decrement the counter. So at the end we will have to have the reversed result, and we will just return the first initial stack. So here, time complexity, since we're using the for loop, and within the for loop we are using the while loop, it will be like so here is n number of elements, so here it will again n number. So in a worst case, not in worst case, but in a generally it will be n number n minus 1 divided by 2, so it will give us n squared. So time complexity will be big of n squared. Memory will be, we defining one stack, which is the number of elements, plus one temporary variable and one counter, 1 like 2, so it will be big of n.